Hello and good morning, everyone. Um, let's wait for a couple of minutes for everyone to join and then we can start today's session. Okay, so let's start with today's session. Anyways, it is going to be recorded, so others can join in. Or else we can start with a short video in the beginning. Uh, just give me. Yes,
Yes, sir.
yes,
You can start the session, sir.
yeah, sure. So, in like the whole day today will be revolve around CAD for robotics. So, for the people who don't know, CAD stands for computer aided design, and majorly people understand the importance of CAD because it helps us in manufacturing, it helps us in designing proper parts for robot. But the integral part, why is it important in ROS, is because CAD itself, we can convert this CAD into a 3D model which you can use into robot operating system to simulate. So if our CAD is made perfectly, if our designs are made perfectly with proper weights, with proper dimensions of the robot, we can simulate it as if it is in real life. So without wasting any money on the hardware, you can actually try out different things on your robot. You can understand how it will behave in the real world. If there are any changes needed, it's like you can make the changes and you can test it again. And this rigorous testing and simulation, this will help you save a lot of money, and that is the reason CAD is important in ROS and like in every part of the life. There is some message, sir. I have worked with my ID and I joined with the other IDs today's session too. uh, I'm not aware of if you can join it with other session, but I guess you can. So please try joining that way. So just to give you a brief about what all designing softwares are there for CAD, I will show you a short video. Give me some time. I will play it back. So the first question arises while using like while making using CAD for robotic systems is which software should we use? There are a lot of options, and from those options it is very confusing to choose which one to use because there are like softwares like SolidWorks, there is CATIA, AutoCAD, and a lot more. So which one is the best one to use? So I made a video a couple of years ago. So let's start with that. It says best designing software for robotics, and which software should you use for designing robots, especially for ROS. So it's not just that uh, Fusion like the softwares that I will be telling in this video are the only options. There are a lot of options you can use, but I will be defining why I am stating this software as the best software. So let's watch this video. Hello everyone, my name is Pranshu and welcome to my channel. Before starting with this video, I would like to tell you something. Initially, I had planned to make just one video explaining how you can design your robot for ROS simulation. However, many of you guys requested me to make a detailed tutorial of designing software, and that was making video very long. So to cover all the details and not to make it a boring lecture of 1 to 2 hours, I have divided this series into 3 major parts. Is the audio audible properly?
Yes, audible.
Yes. And this is the first part of the series. In this video, we'll look into the different softwares that we can use for designing our robot, and we'll see pros and cons of each of them. And later, I will tell you which software I personally prefer and the reason behind using it. In the further part of the series, we will see how we can design our robot and create their mock-ups, renders, and animations, and
and finally how to use them into a raw simulation. To make sure you don't miss out on those videos, don't forget to subscribe to my channel and ring the bell icon so that you get notified whenever I upload those videos. So without any further ado, let's get started by looking at the options of softwares that we have for robot designing. First in the list is the oldest and the industry favorite designing software, SolidWorks. As Wikipedia says, SolidWorks is a solid modeling design software which is published by the Dassault System. It is the same group of companies which makes the controversial graphics. Anyways, SolidWorks has been around for almost 25 years now, so we can say it's quite a mature software. And over these 25 years, it has been grown a lot with many feature additions over time. And it has been industry favorite right from the start due to lack of options. The company has used this lack of competition to put up an unrealistic price over the license of the software. Even the student version of the software costs you around 10k rupees for just 1 year, which is too much for an average student to bear for just a software. Also, it is quite difficult for beginners to learn. Due to these two major factors, I don't personally prefer SolidWorks. So to cater the high cost factor of SolidWorks, we have good and open source software, Blender. So yet again, as Wikipedia says, Blender is a free and open source software toolset used for designing, creating animations, visual effects, etc. Blender is a really good software which is widely used in animation and VFX industry. But the major strength of Blender turns out to be its own weakness in robot design. As Blender is used in animation, it is really good sculpting software. You can make really cool looking organic shapes using Blender. But when it comes to mechanical designing, Blender lacks a lot of properties. The results obtained by Blender for robot designing are not quite satisfactory and also doesn't meet the industry standards. But I must say, it is a software worth learning to give cool aesthetic effects to your models.
With the RockLock Quick Change system from Fifth you can simplify your programming.
That brings us to our third option, creating or designing robot using UIDF, which is directly supported by us. You might have not heard about this before, but UIDF stands for Unified Robot Description Format. It is an XML file format that is used to describe your robot structure to raw simulation environment. As the name suggests, it is a detailed description of your robot, right from the information about the links and joints to its inertial and mass value, and also friction and everything. And so no matter which platform do you use for designing your robot, at the end it is necessary to convert it into UIDF so as to use it in raw simulation. But designing a robot from scratch in UIDF is really a tiring process. It also limits you from using complex structures which can be easily done in any dedicated designing software. You can definitely import meshes to make complex structures of your robot, but then aligning the links takes a lot of time. And that's the only reason I don't recommend directly making your robot in UIDF. These were the few top robot designing software options. But before getting to the best software, here are a few honorable mentions. Tinkercad. Autodesk Inventor. Autodesk Maya. CATIA. PTC Creo. Finally, Autodesk 123D Design.
With the RockLock Quick Change system from Fifth you can simplify your programming.
So if you have reached so far, I'm pretty sure you really want to know how to design the robot with the best possible tool. So the software which I personally use and recommend to the people around me is none other than Autodesk Fusion 360. Fusion 360 is the first 3D CAD, CAM and CAE tool of its kind. It connects your entire product development process in single cloud-based solution, supporting the digital manufacturing process. It is supported on both Windows and Mac, unlike SolidWorks, which is only supported on Windows. Fusion 360 supports all file formats, so no matter where it was first designed in. So if you have an existing SolidWorks file, you can still edit it in Fusion 360. Process of converting 2D drawings to 3D models and vice versa is really easy and quick in Fusion 360. Also, Fusion 360 design files are stored directly on Autodesk Cloud linked to your account. So you can access it from anywhere in the world from any system you want. For example, when I am here at my workplace, I design on my PC right over here, and whenever I go home, I can continue working on the design on my laptop. Also, there is no fear of losing your data, nor does it clutter your system storage. And as it is a cloud-based system, you can have an hassle-free collaboration on a single project between you and your teammates. It also has a mobile app which comes in handy to quickly view your designs on the go. With Fusion 360, you can design mechanical models, create organic shapes, and also animate and render high-quality images and videos out of it. And yes, you can also perform stress, thermal, and manufacturing simulations on your models. By the way, this video is sponsored not by Fusion 360. For that matter, I would love to if they do so. But anyways, all what I have said is from my personal experience of using Fusion 360. Autodesk also offers a very useful educational license that allows students and educators to use the software's full version with almost all the functionality without paying a single penny for over 3 years. I'm using the same license right now. And if you are not a student or an educator, even then Autodesk provides a free to use personal license, which is more than enough to get started. I will put all relevant links down in the description. So coming to the conclusion, I would like to say no matter what software you use, in the end of the day, your skills are what matters the most. Just using a specific software doesn't make you expert in anything. So along with software choices, do work on your skills too. I hope you found this video very insightful. If yes, then don't forget to give a thumbs up. Also, you're not.
Okay. Yes, Mahesh, you have some question? Yes, Mahesh, sir. Okay. Okay. So after looking at this video, does anyone has any questions? So the ultimate aim why we are using SolidWorks is due to its cross-platform ability, so that it can be used by multiple people at the same time, as it is a uh, cloud-based software. So it is easy for collaboration. So it's not just me working on one design. There can be multiple people working at the same time. SolidWorks has collaborative features, but at the same time, it doesn't support it. And along with it, makes the complete manufacturing process. So here, as I said, we can make a 2D design, we can convert it into 3D model, then even we can convert the 3D model into 2D drawing that can be sent to manufacturers. After that, we can also do generative designs. These generative designs are used a lot in automobile industry to save on the hardware cost and the raw material cost. So here is an example. You can see that there is this caster wheel, but this caster wheel doesn't need to have this complete steel part. What does it need to have? It just needs to have this green part, which is the rotating part, and this is the axle of the wheel. These are the most important things, and it should not collide with these red things. So if we tell Fusion 360 these things, it will make an optimal design. See, it has given 3 options. It might look weird, but these 3 designs are best. Like, it saves the most material, at the same time it gives you the most strength which it can provide. So it gives you an optimum solution. So these generative designs are used in industries to save a lot on the material cost. The third thing you can do is you can make a realistic render. So even in SolidWorks, it is possible to make renders, to make like a put your robot into a scene, but here you can adjust lightings, here you can adjust a lot of more features, so that you can get a proper render, like a photorealistic render. You can also animate things. So once you animate them, you can make a video out of it to show to the client as a as a mock thing or something like that. One more thing which we can do is it has its own simulation workspace. So simulation like stress testing, thermal testing, and a lot of things can be done over here. Apart from that, it has also manufacturing workspace. So you can make G codes for your CNC machine, for your lathe machine on over here. So just provide your designs, and this Fusion 360 will give you the output parts for the G code. And at the same time, uh, there are a lot more things, like you can also make electronics design inside this. So if you make a electronic design, it gives you the complete bill of materials. It will also do the electronic simulation. So if you want to see if all the paths are correct or not, if you want to see if air will flow from a certain when we work in industry, we have small enclosures in which the CPU is kept. So we have to make sure that airflow is proper so that this electronic CPU doesn't heat up a lot. So all those simulation can be done within Fusion 360. You don't need any other software. Previous to this, industries used to use multiple softwares, like for this fluid simulation and for airflow simulation, they used to use ANSYS, and in some cases for designing, they used to use SolidWorks or Creo. But here, Fusion 360 is a combination of all of them, and hence the name is Fusion. And that's the reason a lot of industries which are upcoming right now are using Fusion 360. So today we will be using Fusion 360 to design a base. I will show you some basic designing, and by the end of the day, we will be making our own robot using Fusion 360. And after that, we will be converting it into URDF. So why URDF? So as I explained yesterday, URDF is the Universal Robot Description Format. So I will just brief you about it again. So UIDF includes properties of your robot, such as its inertia, its colors, and its textures, and a lot of more things. Along with that, UIDF also enables you to simulate your robot in Gazebo. So if you are using SolidWorks software, if you are comfortable with SolidWorks, there is a plugin called as SW2 UIDF. What does it do is, SW means SolidWorks, then there is 2 URDF. So why is it used? It is used to convert SolidWorks models into URDF. So you can download it over here. It is on the ROS official website. And they have also provided some tutorials over here. Okay, SolidWorks to URDF, export, everything is given. I'm not sure about if it is available for Creo and CATIA, but it is available for one more CAD software, which is Fusion to URDF. So Fusion to URDF, as the name suggests, again, it is converting Fusion 360 models into URDF. So it's an open source project. I have been contributing to this since a very long time. And here you can see this was the robot model, and we can put this robot model into Gazebo. We can see the center of mass of each of the object that is automatically calculated. We can see the collision, it doesn't collide with itself. It can collide with the objects. All those calculations are done. Then we can see the inertia of each and every link. Everything is done automatically. You don't need to do anything extra in it. It's a very simple thing. And here also they have like this is done by some Rohit Kumar. So he's just working on a biped robot using Fusion to URDF. So even that you can work on it. So that's the whole and sole reason due to URDF we are using Fusion 360. So now let's understand about Fusion 360. So this is Fusion 360 software. Whenever you open, you will have a environment like this. Many of you might be familiar with some CAD softwares, and all the tools are on the top. So here, if you want, you can get more tools. So here is all the things given. It's just like Microsoft Word, where everything is given on top. Okay. So whenever you open Fusion 360, there are a couple of things that you need to do beforehand. So first thing is click on the profile photo that you see. and go into preferences. Once you go into preferences, the default modeling orientation by default will be Y up. So even in SolidWorks, if you see uh, Y up, like the Y axis is at the top. So if I apply it, this is by default. So if I open a new thing, new design, yeah. So here you can see a small cube. It will show me the orientation of axes. So it will show me that Z is the front axis, front is Z, right is X, and top is Y. So this is how the axes are placed. But if you remember yesterday when we were testing everything on this thing gazebo, X was the front axis, Y was the axis on the left, and then Z was the axis on the top. Yeah, so that's the reason we are going to change the preferences. So if I again go into preferences, here default modeling orientation should be Z up because we want the Z axis to be up. So I will just apply OK. And now if I create a new design, here you can see, so this X is going to be the front of the robot, Y is going to be the left side of the robot, and Z is going to be the top of the robot. Okay. Next thing is, there is one more thing that you need to change into preferences. So again, I will open preferences. Here, in design, default units, design. Just make sure the default units are set to mm. Sometimes it is in inches, sometimes it is in centimeter, depending upon like whenever you download which IP address of your PC is being set. But just change it to mm because we will be designing all the robots in the dimension. Is millimeter. Okay, so I will just apply OK. Now if you can see, there is a thin red line passing like this. So this is the x-axis, and there is this thin green line which is the y-axis, and this is the center of our design. We can just zoom out and we will get a something like this. We can rotate. So how am I doing it? So to zoom in, zoom out, you can just scroll in and scroll out. If you use a mouse, you can scroll in, scroll out to zoom in and zoom out. Now if you want to move this complete thing, press the scroll button. Now your cursor will be changing to a four-way arrow. So why is this? This is panning. Even you can see this icon, this is for pan. So whenever I click the scroll button, this pan button will be highlighted, and this I can move around. So if I want to move the any object around, I will use this. Now if I want to orbit around something, what I can do is I can press shift on my keyboard, and then I will press on the scroll button. So as you can see, now it is changing. Instead of four-way arrow, it's changing to a rotational thing. So I can orbit around it, orbit around any object. So if there is any model over here, I can orbit along it. Okay. Even if you want, if you don't want to click on buttons, you can just click here pan. So for temporary until and unless you click over here again, your mouse will be changed to pan. Again, if you click here, your mouse will be changed to orbit until you click over here again. Okay, if you click on constrained orbit, it will be constraining your motion. If you put free orbit, see, it will rotate like this. But usually I prefer constrained orbit because I always need Z axis up. I don't want it to rotate because it makes things confusing for me. So that is my personal preference. Okay, if you press escape, the selection will be gone. Okay, so let's make sure it is in constrained orbit. Yes, it is. Okay, then there is cube here at the top. This if you like just lost somewhere, if you are doing something like this and you want to go on to home position, just hover your mouse over here and click on the home. So it will orient the complete model to its home position. Okay, the next thing is, if you want to see the top view, just put it over here top, and you can rotate it if you want. Then if you want to see any particular view, left view, side view, all these things you can watch it from here. Again, if you want to go on home, you can go like this. And you can also click on this cube and rotate like this. So everything can be managed through this small cube. Okay. Next thing that you need to know is the tools. So is the workspaces. So here are certain workspace that I showed you in the beginning. So there is a design surface, design workspace, there is generative design, rendering, animation. So we'll be looking at all of them later in this complete thing. But majorly we will be just using design workspace. Okay. Now even in design there are multiple types of designs that you can make. So this solid is for basic solid designing, like you will be making it using basic geometric shapes like cubes, cuboids, cylinders, spheres, and some basic geometric shapes. But when it comes to surfaces, let's consider you want to make something out of thin sheet of paper or cloth. At that time you can use this surface workspace. So what does this surface do? You can see here, you can cut the edges, you can stitch them, you can unstitch them. So this is while using, like let's consider if I am using a thin sheet of acrylic to make some robot body. So at that time I can use this surface to make curves and stuff like that. At the same time, if I'm working with uh, meshes, I can use this mesh workspace. And this is another commonly used space, which is sheet metal. So sheet metal is whenever you are working with metal sheets that needs to be plasma cut, and once it is plasma cut you need to trim them down, then you need to what we say, fold it. So when folding, it's not exactly a 90-degree fold, it's a curved fold. So all this it takes care of. So here you can see it's flanging, so it takes care of that. You just need to make your model and it will automatically understand how much sheet of metal is needed. It will take all the curves into a consideration. Here you can define the type of metals that we are using based upon their ductility and malleability. And yeah, and finally there are tools. So these tools we will be looking at the end. So majorly it's just like if you want to do draft analysis, if you want to do iso curve analysis, so there are some analysis. If you want to check the center of mass uh, of our bodies that we are making. Okay, so there are a couple of tools, and there are some add-in tools as well. So as I said, Fusion 360 has its code open source, so some part of it is open source. So people are able to create their own plugins for Fusion 360. So majorly plugins can be built using Python programming or C++ programming. So some people have made these program. This is the UIDF program that we'll be using. I will be telling at the end how you can add that. But here are some plugins for making a bolt. So if you want a bolt of a specific dimension with a specific threading and specific height and everything, you can make over here. If you want to make a bottle, means instead of designing the whole thing, you can just put in the dimensions and it will create automatically. It will make your work a lot easier and faster. So that is again one of the major reason why people are adopting Fusion 360, because it makes the complete work timeline much more faster and much more efficient. Okay. Next, if you want to design some spur gears, you can directly use any of the script. Python is works also well. C++ also works really well. So you can just put in what teeth you want. So I will just show you if I want to this. If I want, I will just run it. Yeah, so it asks what is the standard. It should be metric or English. So metric, like the units I'm talking about. Then what should be the pressure angle? What is the module? So what is the module? Module is the size ratio of pitch diameter by the number of teeth. So just whatever pitch diameter you want divided by the number of teeth, that will be your module. Define your number of teeth over here. Do you need any backlash? So this is just because some people 3D print it. So in 3D printing you get a little bit of error if it is a not really good 3D printer. So at that time you need to account for some kind of backlash. Then if you want some fillet, like a curved thing at the edge. What should be the hole diameter? What should be the gear thickness? Just put it over here, and automatically everything will be calculated. So let's say if I've put everything, I will just press OK. Without doing anything, I will get the desired gear that I wanted. I didn't even do anything in it. Still, I got the gear, and it will perfectly mesh if everything, every dimension is correctly provided. Okay. So again, I will undo it because we don't need a gear right now. But yeah, these are how tools are made. Even here you can get 3D printing simulations. You can directly send it to a printer if it is IoT enabled, and this is for the people who are living in US, that they can directly get quotes from 100K Garages, which is a 3D printing company. So if I make anything, I can just click over here. It will send the 3D file to the company, and it will tell us how much cost it will be to print those things. So it's completely yeah. Uh, Mahesh is asking how to use Fusion 360 in online mode. So Fusion 360 by default is in online mode. So here, if I click over here, it says that I am working online, view job status. So here I have a couple of projects that I have made. But if I go into the offline mode, see, I will just open one. Yeah, these are some projects that I've made. If I close this, if I work in offline mode, it will ask me, do you wish to work in offline mode? If I press OK, all these models won't be available. I just have this model on my computer. That's the reason I can access this model, but rest of them are not accessible. Understood? So that is how, like right now it's in offline mode. You can see a red dot over here telling it's in offline mode, working offline. Again, if I go online, all this will have me access.
So,
If I,
so it is
yes,
better to work online.
yeah, no, it's not like, it's better if you have a complete team. It's your wish if you want to work online or offline. It doesn't take much of the processing power or anything. Then there is one more thing. If you want to share it with somebody, if let's consider I want to share this robot, I can just right click and I will click on share public link. So here, do I need to share the latest version with anyone using the public link? So means if I share it today, and if I make some changes in the evening, and if tomorrow you test it out, do you want to see the previous stage or the current stage? So if you want to automatically update the model on the link, you can just turn this on, and allow items to be downloaded. Do you want it to be downloaded or not? If not, you can just close it. If you want the person to download it, to work on it, keep it enabled. If you want certain kind of password protection, you can add that, so that even if your link is public, until and unless the person has the password, he cannot access it. So for example, I will type FDP is the password, and I can just copy this thing, and I can share with you. I will just close this now. I will share it on the chat if anyone wants to check it out. So I will just open the link that I shared in the chat right
Just
now.
little bit zoom your screen, please.
Yes, sure. Yeah. So now whenever I click on this thing, the link that I've shared on the chat, it will ask that this item is password protected. Please enter the password. So the password was FDP, submit. So it will start loading inside a web viewer. So here you can see if the person in front of you doesn't has any CAD software, it's completely okay. He can just watch the complete 3D model in a web viewer. And as you can see, there is background, it's photorealistic render, even shadows are rendering. So this is really good while sending to the clients. And if clients want to say something, like if the clients want to say change this motor driver, they can just draw something. Okay, here you have a complete free access. Yeah, and here I can just add text saying change motor driver. So the client can just send it to me so that I understand okay, this we have to change, and I can just save a snapshot of it. So here I can draw, I can edit, I can just make an arrow like this. Okay, this arrow here. So there are a lot of things that you can do. It's good on the client side because whenever we work with clients, they are not the people who are like who are very good in CAD or something. They won't understand, but they have to tell me ki, ha, that green thing, just change that green thing or red thing. Usually people say like that. Even they don't have a powerful PC. Some people just use an iPad. On iPad you cannot run any kind of CAD software. So this is really good because in iPad they can just open a web browser. It can be Google Chrome, it can be Safari, and they can view the model in iPad. So not only iPad, but Fusion 360 also has Android app in which you can see and access all your designs, Android as well as iOS app. So if you have an iPhone or if you have an Android phone, you can view your designs, you can show it to your clients then and there. So it's really very easy to share it with anyone. Okay, then here you can see hide markers. Then there is a camera interactions. You can just select the focal length. So if you the view is set to orthographic, okay, no problem. So if you do that, you can see how it will look in actual camera. If you are doing a photo shoot with your robot, then you can have a first person view as well. So I will, okay, got it. So first person view will be like I am there in a room. This is the room with some photo lights and stuff, and this is my robot in front of me. I can also move around. So now I am moving backwards. I will keep that robot over there. I will just walk towards robot. So it's like a game in which I am moving. Then there is zoom in, zoom out. There is panning. There is orbiting. If I want orbiting from center, I can just select it. I can also see the size. So if I want to measure the distance between this point and let's say this point, so it tells me it is 65 or 65.7 mm. So it tells me the dimensions. I don't need to bug the designer again and again. What is the distance? What is happening over here? So all these tools are provided. Not only these, but you can also like measure the angle. So let's think of this part. There is an hexagon over here. Let's see if I can get the angle of this hexagon. Yeah. So this is one this thing. Yeah, this is the other way. Okay, wait. I will go in angle. Yeah. So I will just click on the edges. And now I understand it's 120 because it is an regular hexagon. So all these tools I can add, do, and this is not even I have downloaded Fusion 360. It says if you want to download, you can download, open it in Fusion 360. So it will download Fusion 360 and open it in that. Or else, if you don't have Fusion 360, let's consider if you have a SketchUp designing software by Google, you can download a SketchUp file for that. If you have a SolidWorks, you can download a step file. If you have Autodesk Inventor, you can download an Inventor file. If you have Fusion 360, you can download a Fusion 360 archive. IGES, I don't know for exactly where it is used, but for most of the industrial designs I've seen, IGES is also used. You can download that. For Blender, FBX is used. For 3D printing, STL is used. For laser cutting, DXF is used. For AutoCAD, where we are using engineering drawing, DWG is used. So all these things you are getting an option to download it. You don't need to do any extra additional work. And here even I have made some animations with this model, so I can view those animations. So if I go to storyboard 1, let's see what kind of animation it is. I don't remember what animation I made on this. So let's see. It will take some time to load the complete animation. Can I play the animation over here? It should actually work. Okay, here is the play animation. Yeah. So here you can see I made a like parts diagnostic video with it. Let's see this animation.
Sir, excuse me, this explosive, is it automatically generated or you have to create it
Uh,
separately?
there are two methods to it. We can generate automatically as well, and we can do it manually as well. So I will show that in when we learn about animation workspace. So here you can see auto explode one level, auto explode all levels. So there is an automatic version as well. But I will tell you when we actually design the robot, and then we can do this. Okay.
Okay, okay, sir. Thanks.
Yeah, but it is possible. Yeah. So there are like if each and everything will take some time to load. Yeah, there we have it.
Sir, this electronic circuits also, did you create in
Yes,
Fusion
yes,
only?
yes. So if even if you zoom in, it has all the small capacitors and stuff like that. Let's see.
So you can do PCB design also in Fusion
Yes,
360.
yes, exactly. You can do PCB designing as well. Even if you once you design the complete PCB, it will give you a complete bill of materials of that PCB. So here I have done a rotation animation, very basic rotation. So there are a lot of things that you can do with it. So let's get back. Yeah.
Even the processors also, can you select Intel processor?
Yeah. So there, when I click here, like new electronics design, okay, there is also electronics library, but I will select on design. So here I can design a new PCB. So yeah, so it has complete elements for the PCB designing, and here it should be pushed to 3D. So here what we do is first we make a 2D design and then we switch to a 3D PCB. So here you can make a mock-ups of those. How much layers of PCB do you want, and about the this thing, the parts that are used, right? So here I guess in manufacturing or some, yeah, here you can then put it into ANSYS and use it if you wish. Yeah, libraries. So open library manager. So here are like I have not made anything right now, but here it will fetch some libraries. So these libraries are of the parts that are available.
Okay, sir. Sir, I
Yes.
think this is a massive software and it
Yeah.
will take about 70 to 80 hours to learn on this.
Yes, exactly.
Means, do you have your uploaded videos showing how to learn in SolidWorks?
Uh,
Because it is, we don't know how to learn this. This is
uh,
also a big task
yeah. So
unless we have videos to
on
learn.
Fusion 360, I will be telling you a couple of things today. Okay, in today's session only, I will be showing you some basics Fusion 360. Apart from that, I have not any personal videos, but there is a really good YouTube channel called as Product Design Online. If you search product design online, if you search for it, yeah. So this is a really good channel that you can follow for Fusion 360 tutorials. So he has done a lot of tutorials. So right from the like sheet metal and to woodworking, how you can export into DXF, how you can laser cut it, all those things he has explained. Even nested parts. There are a lot of tutorials from this. So this is a really good channel, Product Design Online.
Okay, sir. Thanks, sir.
Yeah.
So, has he also told how to do the design and
Yes.
electronics also?
Yes. So if I search electronics, yeah. It was a really old video, I guess. Snap joints. Just a minute. Fusion 360. Electronic. It was PCB. Sorry, PCB. PCB design tutorial. Fusion 360 has their own lives. So they have made a line following sensor in this. Then they have tutorial schematics, everything. So this is by Autodesk itself.
Okay, sir. So
Yeah.
what is that? That is that site called as Product Design.
Yes, product design online. And there are some tutorials by Fusion 360 India and Autodesk Fusion 360. So this, like in this Autodesk Fusion 360, again, they have a lot of tutorials about how industrial things can be designed in it. And in Fusion 360 India also, they have a couple of team meetings and stuff. But here each and so this person showed how we can make a laser cutted design to make a table for ourselves. Then there is complex design structure. So like I don't remember what it was called. It was some mechanism like a spider thing walking. So this person explained that. Then there is this thing Fusion 360 electronics getting started. This is a 1 hour video. This is really nice. You can check this out. I will just share the.
Sir, that I think is a 8-link strand beast design.
Could you come again?
Sir, I think what the video you just now shown was a 8-link strand beast design. He made a strand beast in the seashore. Seashore.
Yes,
Strand, it is called strand beast. It is an 8-link mechanism design.
Yes. Yeah. So it's based on Theo Jensen's mechanism, right?
Yes, correct. Theo Jens, correct.
Yeah, I was not remembering the name.
Because getting a 8-link design for single degree of freedom is extremely complex, and he somehow cracked it.
Yes.
Till now, I could not figure out how he did it.
So all those simulations can be done in Fusion 360 as well. So if you go through this, all these webinars are like 1 hour long. So they are very complicated and in-depth things. How you can make turning and turn mill in Fusion 360, creating 2D professional drawings. Everything is provided. So just go through these official Fusion 360 channels as well. They are really informative. But today, I see even this electronics, what's new for Fusion 360 electronics. So they have added some updates. So even you can check out these videos. I will be showing some basic tutorials today. And then it's upon you how much in depth you wish to go, because CAD is not this thing. CAD is not something that everyone likes. So let's see. Even here there was an electronics library update. So they usually update gives on like pushing new and new updates. So recently they provided it for Jepson Nano as well. So here you can see if I want any connector, I can check the connector. I can browse it. If I want any wireless radio frequency, wireless transmitters, receivers, transformers, there are some tutorials. And there are so many things available. Like the memory, I can download it. I have not downloaded because I don't work on electronics on this PC, but everything is available. So, and each of them are available from different manufacturers. So these are from Seed company. This is from any person, I guess, Hetal at PCBlayout.com. Then these are made on Eagle PCB. So even Eagle is a good software for PCB designing, but they have added of all the features of Eagle into this thing. So the reason behind, and that's the reason the name of this software is Fusion, because it's a fusion of everything. It's just one software that does all the work for you.
Yeah, okay, sir. So maybe we may be able to have servo motors also.
Yes.
Feedback control system means, can we do feedback control design?
No, control system you cannot do in this. Control system is not possible.
Okay, sir. Thanks.
But usually they provide update very regularly. So, and even they ask such questions, like they take on feedback from the user and they actually implement it. So I have a lot, like whenever I face any problem, I have given feedback from here and they immediately push an update. And as it is an online software, it takes like 2 or 3 MBs to just update. It will update very quickly. So they push an update, and those all updates are completely free. Like SolidWorks, every year they come up with a new version, right? And you need to buy a new version, this thing of it, new licenses of it. But in Fusion 360, it's not like that. It's just one software and you will get updates for lifetime.
Oh, okay, sir. Thanks.
Yes. So, yeah, coming to the designing part. So now let's start with a very, sir, it is asking for password. Okay, so password is FDP. password FDP. Okay, so coming to the main thing, let's see the designing part, and we will be exploring all these parts one by one. Okay, so let's start with designing a very basic robot. So what we need to do for designing a robot is we'll need to make a sketch. So there is an option over here to create a sketch. So I will just click on create sketch, and it will ask on which plane do you want to make a sketch. Do you want it on this plane? Do you want it on this plane? Which plane do you want? And it also show you the axis so that you don't get confused. So always remember, yesterday also I told, red is the x-axis, green is the y-axis, and blue is the z-axis. So even if I was oriented in a wrong way, something like this, I guess, if I would have been oriented, still I would have been able to understand ki, okay, this is red, this is thing. So I can understand which plane I want to draw on. So I can select a plane whichever I want. So I will be like drawing on the XY plane. So when I use the XY plane, you can see I can see the red and green lines. If I select XZ plane, which I'm doing right now, see, along the blue line, I get the another thing, right? So I want this one. This is the base plane. So now I am getting a top view of whatever I make. This is my center. I can zoom it, zoom out, normal controls as I explained previously. So now let's make a very basic robot. I want a circular design. So, and I want that circular design to be, let's say, 30 centimeters. But here we are giving it in mm, right? So, wait a minute. Yeah. So this is, if I just type 30, this is 30 mm. So either what I can do is I can type 30 and cm in front of it. It will automatically make it big. Okay. Or what I can do is I can write 300 and enter. So 300 equals 300 is mm. Or you can just type 30 centimeters. If you want in inches, I can just put 12 and double inverted comma. So it will become like 12 inches. And we are giving a diameter of it. So how did, again, I will come again on this. So once you go into the sketch mode, you will get a lot of tools over here. So here there is a line tool, there is rectangle, circle, spline. If you want to mirror anything, and if you want more, you can get it over here as well. You can make circular patterns, rectangular patterns. If you want to make regular polygons, circumscribed polygons, inscribed polygons, arcs, which you have 3-point arc, everything is given over here. So you'll just click on circle. Even in circle, I have multiple options over here. There is a 2-point circle, there is a 3-point circle, 3 tangent circle. This is a center diameter circle, and this is 2 tangent circle. So let's say, like by default, center diameter will be clicked. So like I will just click on the center where I want it, and I can give the diameter of the circle. So that is the reason it is called center diameter. There is one more way which you can do is 2-point circle. So here if I click on 2-point circle, if I click over here, I should be able to, I am clicking one point and then I am giving the next point wherever I want. I can make it an angle if I have some CAD like engineering design limitations. If I want some kind of lines to be attached to it, so we can do like that. So I guess before going to the 3D designing model, let's start with some basic CAD things. So I will just search engineering designs, because directly going to a robot will be a little bit complicated. Let's there is a great book by I don't remember the name. Wait a minute, 2D engineering design. Yeah. So let's start with some sample design, something like this, or let's start with a very basic thing. Let's see if we can get any design. Okay. These are a very bit complicated. I need some basic things. I think I had it. Wait. No, this is not the right one.
Or maybe you can select engineering drawing by ND Butt.
Yeah, just a minute. Engineering drawing by ND Butt. Yeah, this was the book. Yes, I used to refer to this when I was in engineering, and I've almost forgot the name of the book.
Yeah. And one more is there. Machine drawing is also there by ND Butt.
Okay. That was the reason I was unable to recall this book, and did it like almost 7-8 years ago.
This book is nationally popular. ND Butt.
Yes. So when I learned Fusion 360, it was in the same way. Like I referred to that book and I tried designing those things in Fusion 360. So this is the best way you can like use it to learn any new CAD designing software. Even if you know SolidWorks, it's okay. Just take a book, start from basics, starts from implementing very basic designs. Did anybody raise the hand? No. Okay, it's taking a lot of time. Yeah, there we have it. Yeah. So these are very basic shapes. Let's start with this. Does these have dimensions? No, they don't have dimensions. But okay, we can approximately take whatever dimensions we want. Or else there is one more very nice way we can use in Fusion 360, which is taking photos. So I will take a screenshot of my screen. So here, let's say I want to make this design. Okay. So I will just take a screenshot. It has been saved. So, and here I can add a canvas. So I can click on insert and insert a canvas. So here canvas is just for referring. Okay. And I want to insert it from my computer. So now if I go to my desktop, there will be the screenshot that I took right now. I will open it. Okay. And which face do you want it? I want it on this face. Now it will ask me how big do you want it. So I can make it however big I want, however small I want. But if you want to get an exact proportion, like let's say if these dimensions were given, if this was a 50 mm hole, then how I can do it? So I can just, here we have created a canvas on the left hand side. I will click here, right click and calibrate. So calibrate, what does it do? It tells us like I want to calibrate it. So here on calibration, I will click on 2 points, which is the diameter. So this is 1 point and this is the other point. And how much do you want? I want it to be 50. Now if that is 50, everything else will be scaled automatically. If I want to move it, I can move also. I can just edit the canvas. I can move it up and down wherever I want. However I want, I can move it. I will just move it by 3.5 mm. This looks good to me. I will just move it so that this center aligns properly. It's not necessary, but it's just my OCD you can consider, but it looks good to me if we do that. Okay. Yeah. Okay. So now we have this design. Now we can trace it. So this will be a tracing thing that we can do. So now I have selected circle. I know this is a center point circle. So I will just create a circle with 50 mm diameter. Done. If I want to show this as a dimension, I can click D on my keyboard. If I press D and if I select this circle, see, I can show it as like this, 50 mm. It is asking, are you sure it is 50? If I change it over here, it will be fixed. If I, instead of 50, if I do 60, it will increase its size. But if I am telling it's 50, yeah. So here we will get the dimension, sorry, diameter symbol, and it will say 50. Now there is one more circle. Again, I will click on circle. If I come close to this point, I can see, I can align to any point in the grid. But if I come close to point, I can see a small circle coming up. What does that circle say? It states that it's a concentric thing. Now this circle should anywhere be around 100 mm, I guess. Yeah, there we go. This is like a 100 mm thing. But instead, this is not a complete circle. If you want, you can just make a complete circle. If you don't want, what you can do is you can just make an arc. So as we are learning this software, let's learn about different arcs. So in arc, I want 2 to 3 points. So I will just connect arc. Here I can see a 3-point arc. So here, if I click on 3-point arc, I have to click this point, and this point. It will create an arc automatically. There is one more way to make an arc, which is the center point arc. So if I know this is the center, I will click this center. I will click one point over here, and I can make arc however big I want. And there is one tangential arc, which will be using over here. But again, in CAD designing softwares, there is no right answer for one specific problem. The same problem can be solved with a bunch of different things. Like I said, if you want to make a circle and then use it, you can make a circle. If you just want arc, you can just use arc. So let's use an arc here. So here I will just select this. Maybe you can use a 3-point arc. One click here, second click over here, and the arc I want up till here. So now I have an arc. If I click on this eye icon, this will get like it will hide itself. So I can use this. So we have an arc right now. Similarly, if I want a straight line, I will click on line. Over here, I will make a straight line, something like this. Let's say it's 35 mm. Now here again, I want a curve kind of thing. I want an arc. So let's make an arc. Here, let's make a center point arc. So where should be a center point? I will just considering over here. If we have dimensions, it will be much more easier. And I will select a point. And now I can make an arc wherever I want. So it's a 90-degree arc. Done. If I hide it, see, it's really easy. Again, a straight line coming from here, and then again an arc, 3-point arc. So I guess this is okay. Wait, not a 3-point arc, a center point arc. So this has become a little bit bigger, but now even if it is bigger, what you can do is you can select this, press M to move, and now you can move this arc. So if I want to extend it, I can extend it like this. If I want to move it, I can move it. And rest of the design adapts to its side. So even here, the length of this line was really like we didn't define anything. So now you can see it is extending with the arc, it is reducing with the arc. Even if I do like this, arc becomes bigger or smaller based upon the center point of the arc. So this was the center point of the arc. Hence, it wants to save this. It wants to save the center point of this as well. So it is adapting the design. This is one of the advantages of Fusion 360, which is adaptive design. So this looks good to me. Again, I can make a straight line like something like this, some straight lines here. I'm just tracing according to some dimensions that I can estimate. Now, instead of making the same design onto the other side, okay, what I can do is I will hide this now. I have a design made on one side. I will make a line. And now if I make a line going through here to here, you can see this becomes like a colored thing because it considers this as one solid thing. But this straight line, I don't want it to be like a division part. So I will change the line type to a construction line. So in engineering drawing, we used to draw dotted lines, right? So similarly, this is the dotted line. So if I make a dotted line, as you can see, this is not now completed. So now if I want to mirror this, I will just press shift on my keyboard, keep on pressing the elements that I want to copy. Just a minute. Yeah. Keep on pressing the elements that I want to mirror on the other side. Arc we already have. Okay, so these are all the highlighted parts that I want to mirror. And I will click here, which is the mirror symbol. Now, let's say arc we are using a lot. We want arc on the top. So I can just just take this and okay, arc you cannot do, but everything else you can pin it on the toolbar. So if you are using ellipse a lot, you can pin it to the toolbar. You can make a shortcut of it. If text you are using a lot, you can pin to shortcuts. You can pin to toolbars. All these things you can do. But that's the reason mirror is over here, because by default mirror won't be there. I have created it because I use mirror a lot. Just let's use mirror. Here it is telling that objects are selected, 10 objects. So which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 objects are selected. Really good. What is the mirror line? This is the mirror line. Great. It shows me a visualization. It will look like this. If I press OK, now it has completed to a complete design. Similarly, if we want to refer to anything with dimensions, here is something, yeah, we can use this. Or is there anything better which looks cool? So there is no perfect way I can explain all the tools to you, but it is all about on practice. There is no one single answer which is correct for all of these. It can be anything, however you want. Okay, so let's see if we have any machine designing things inside this. And these are orthographic and coming to the orthographic and perspective mode. So if you guys, anyone of you have worked on these CAD softwares, you know there is an orthographic view and a perspective mode. So let's make a small design somewhere over here. I will make a small cube. Okay. I've created a square. I will finish it. Now I will just rotate it something like 3D. I will select this face, press E for extrusion, or I can just go into modify, and here there is an option for press and pull. So I will just use press and pull. Okay, extrude it how much I want. Okay, 50. So now this is an orthographic view. Why? Because here this line is equal to this line at the back. But in real life, we don't see it in an orthographic view. We see it in the perspective view. So the things which are behind us looks a little bit smaller to us compared to the front things. So how can I change it to the perspective mode? I can right click on the cube, and here I can change it to perspective. So if I make it perspective, see this, now this line looks a lot smaller than this. Now it is in perspective. So here also you can see, if I view it from this angle, everything is converging at the back. So this line, if I follow this, it is going something like this, and this line is not parallel to it. It will converge at some point. But now if I do it in orthographic, you can see this becomes exactly parallel. So depending upon what you want to show, you can change to orthographic and perspective. If you ask me what I use, so whenever I'm designing, I design in orthographic view, so that everything seems parallel. I get to understand how my designs are proper. But whenever I have to show it to the to my client, I change it to perspective mode. For example, I will show you a couple of things that looks very different in orthographic and perspective. So here I was working for one client where we have made a robot. It will take some time to load because it will download it from the internet.
Yes, are these all these designs which you had created?
What did you say?
No, on the left side you have shown some several figures. Are these the figures which you had created, or is it inbuilt available?
Yes, yes. No, no, no. It's all like our designs. We have designed it.
Okay, thanks.
It will take some heavy time to load because all these designs are very complicated. Or it has details like each and every screw, nut, bolt, everything is mentioned in that. So it might take time, but it looks really cool when we like the effect of orthographic and perspective is really visible in that. That's the reason I want to show it to you. Yes, it has been loaded. Yes, there we go. So this is a basic rocker bogie mechanism. So now you can see it is an orthographic thing. So you see it like a small toy, but when I change it to perspective mode, you can see it gets a little bit more depth. We can see the lines converging. It looks better. It looks like a real world model right now, instead of just having these like very boxy shape. Again, if you want to go to orthographic, hello, hey, am I audible?
Yes, sir. Audible. You are audible.
Okay. Orthographic, it's a flat 2D view. Even in orthographic, you can see if I'm seeing as an orthographic, as there is no perspective shift, everything is looking flat to me. But when I go into perspective mode, now I can see the back wheel. Now I can see the aluminum extrusions going in. This is what we see in real life as a perspective mode. Okay, so let's get back to our design. So the similar way as I extruded this box, I can extrude this as well. So I can just select this part, I can extrude it however I want. If I want it to be 50 centimeters, 50 mm, 5 centimeters, I can extrude it that much. Okay, so now we have a 3D model. Similar way, you can make any type of engineering designs in this. I will show you one more. I will select this plane. Oh, wrong plane selected. Just a minute. I will undo it. I can move the bodies around. So now these are created as bodies. Okay. So you can see first it was canvases. So here you can see all canvases. I can just hide or unhide it. Here are all the bodies. So this was body 1, this was body 2. If you want, you can rename it. Like I can rename this with cube. I can rename this to something like drawing 1. If I want to move it, I will just select it, press M to move, M for move, and I can just move it in any direction I want. And if I want to look at the sketches that I've made previously, I will just click, I will extend over here by pressing this arrow. What was the sketch 1 that I created? This was the sketch 1 that I created. What was the sketch 2 that I created? It was a square that I made. So remember, this was the sketch 2 which I extruded. So every sketch is stored as a separate sketch over here. I can just hide them all together, or I can just view them one by one. So once it is used, it becomes a little bit lighter, but yes, you can see this whenever you want. If I want to edit sketch, let's say there is this shape over here, it's very sharp. It might hurt someone. Now, after extrusion and everything, now I want to make some changes. Simply click on this thing and click edit sketch. Now here you can see on the timeline you have gone backward. This all has become light shaded. Why is it become light shaded? So because it is saying that okay, whatever we are gone in the past, we have used the time machine to go in the past, and now you can use whatever you want. So now if I add fillet is like a curve thing that you can add. I will add fillet over here by and what should be the radius? So let's say radius should be somewhere around 5 mm. Yeah, this is good curve. Okay, and I will press enter. Now I want this fillet to be mirrored as well. So I will click on this fillet with a radius 5 mm. Just ignore if I am saying centimeter, it's by mistake, but I mean mm in this. Okay, I can mirror it. Again, the mirror line will be this center mirror line. You can see a structure. Press OK. I will finish the sketch. Now if we come to this part, so here we can see this fillet has been generated over here, but here it is not generated just because we still have this small part. So what did we do? While extrusion over here, I can edit the feature. How can I edit it? So while editing, it says while editing you selected the complete structure. So I will press Control and I will say okay, while extrusion, don't select this small portion, and I will leave my control. Press OK. Now if I zoom out, if I see all the edges over here are curved. So you can go back in timeline, you can make changes however you want, and you can come back in timeline and everything will be reflected as you have changed. You don't need to undo changes, redo it, and again make the whole thing. So even if in further stage of manufacturing, if you have made some mistake, you can just change the things in timeline and you are good to go. You can automatically update your complete design. Any questions on this? Let's see if we have any good engineering drawings on this or not. Or else I guess we have to look for the machine. Yeah, there was some. Yeah, this one is really good. Let's make this quickly and we can conclude the first session for today. Yeah, this looks really good. So what did they do is they made 2 construction lines. So let's start with that. Okay, so let's create a sketch. Here is the create sketch option. On which plane? I want it on this plane. Okay, let's make 2 construction lines. So here is line, type should be construction, and I will make just any type of construction line however I want. Okay, it just should have an intersection point so that we can refer to. What is next? There are 2 circles, 20 and 40 mm diameter. Both are center point circles. And now I will like see, even the circle is coming in dotted because we have not changed the line type. So just give me a moment. Yeah, I'm extremely sorry. It was an important call I needed to take. So yeah, so coming back to our session. So seeing that the circle is still in a dotted line, right? So how can we change it? So we have not changed the line type. So I will just click on it again change the construction type to a normal line type, and now you can see the circle is back as a like a solid circle. So now I will make two circles, one of 20 diameter and another one of 40 diameter. This will be 40. You can see this is denoted like this, here 20 and this is 40. Next, what we need to do, from this construction line below 35 we need to make us another line, a straight line. So let's make another line. So how can I make? Here is a line. Again, it will be a construction line. I will draw from some end, far end, if this is possible. Okay. From here, it should be at 90 degrees and it should be 35 low. And at this point, again, as a line, I will just make a construction. So however you do it in real life, similar way you have to do it here. Next, what is there? From center, there is a 40 centimeter big, this thing, rectangle kind of thing. And total it is of 90 So here what I can do is I can make 20-20 both the sides, or there is one more simpler way. And what is the height? It is 8. So here in rectangle, you can make a rectangle like this from one corner to other. But there is one more type of rectangle that you can use, which is a center point rectangle. I will remove the construction line type. I will click on the center, and now I can make a rectangle like this. I'm just telling it the center and I am telling it the edge. So as we want it 8 at the top, I will make it 8 times 2, which is 16. 8 times 2, which is 16. Why? Because it is going to go half below. So I'm using 16. And the total width of it was 40. So now I have a rectangle over here. Next, here it should be 25, here it should be 25, and overall it should be 35. So let's make that. So from here it should be 25. I will just make a small construction line kind of a thing. From here it should be 25. I got this exact point. See, the point is plotted like this. Now what should it be? It should be overall 90 and height should be 35. So let's do that. I'll create a rectangle, make sure construction line is deselected. Overall it should be 35. Not 35, it was it? It's sorry, the overall it is 20, not 35. This is 20 and 90. So this should be 20 and this should be 90. I make a rectangle. See, now we have created this rectangle. Now we want a tangent to this circle coming straight down. So let's add that. So here I can make a line. Okay. And here if I click on this point, I can create a straight line. And see here the tangent icon is also created. Let's say if I don't know where the tangent will be. For example, if I'm making a line from here and I want to make a tangent to the circle. If I just hover around the edge of the circle, at certain point, it will stop and it will show me this tangent icon. So that means now this line is tangent to the circle. So this is how you can create tangents as well. So I will just click on this and click it here. So now our basic shape is ready. Now all we want to do is we want to add curvatures or fillets kind of thing. So either you can add fillets right now, or there is one more way you can add it. So I will just finish the sketch right now. Whatever I want, these are now small elements, right? So I can select different elements, like this is one, this is one. I can just have different elements. I'm not selecting this now because I just want this one, and I will extrude it. Let's extrude it 25 Now this is a good thing, but we wanted these curvatures with radius 5 How can I add that? So I can select those edges. So this was one edge and this was one edge, right? Here I can click on fillet. And what was the radius? It was 5. Done. Then there are two at these edges. So I will select one edge on this side, one edge on this side. Press F for fillet. Again, it will ask for radius. It is 5. And there are small edges in the fillets in the bottom as well, which has radius 2.5. So let's do that. So if I do this, fillet 2.5. Now if I see it from the top, it's exactly the same like we explained over here. Understood? Now they have defined this circle like a separate circle. So I guess what should be the case is this should be more extruded than the below part. If you want to do that, even you can do that. So here when I extruded, I would edit the feature. Instead of 25, I will just do 10, I guess. Yes. And again, I will enable the sketch. In this sketch, I will select the circle that I want. And I will extrude it even further. So now we are getting an options of cut operation. So it is asking, do you want to cut this side? So I said, I don't want to cut it. I want to join it. So I will join it, or I can create a new body out of it. I can create an intersection, but I want to join it. In this case, I will press OK. I will hide the sketches. There we have it. So maybe these kind of things are used as a coupling and or bearing holders. So everything we have created in a very short period of time. Again, and if you want to convert this into an engineering drawing, something like this, it won't even take 2 minutes for that. Just click on this, click on File, New Drawing from Design. So I will just have to save this design. I will save it in a separate folder, or I have a folder over here. If I FDP add. Okay. So it will ask what things do you want to use. So it says visible only. So change from visible only. So what it will do is whatever is visible, it will use that. I don't want to use this. I just want to use this. So I will click on select. So I can select what elements I want. I want this element. Or I can just cancel it. I will hide this drawing. Okay, yeah. Now I can create a drawing from design, visible only. What sheet of paper you want? I want a A4 sheet of paper. Unit should be in mm. ISO standard, everything. Okay. Okay. Once I click it, it will take some time for generating. Yeah. It will give me a blank sheet of paper. Yeah, there we go. So here, if I want, I can change the orientation of the paper as well. And now here at what scale I want. So as it is A4 size of paper, I can make it as 1:1 scale. Yeah. So, and what model, like what view do you want to see? I want to see the top view. And here I will place the top view, press OK. Now I can show it the dimensions. So here, if I press D, this circle is of 20. Again D, this circle is of 40. What else did they do? They made construction lines. I can make a center line for it. What else did they do? They showed this radius 5. So I can even show D for dimension. I want to show this. Wait a minute. D. Yeah. This R5. This R5. This is R25. 2.5, I mean. This is 20. So I can create again D from this line to this line. I want dimension, which is 20. This is 35. What was it? 35 from this center line. Okay. I can say D from this line to this point, it is 35, 8, 25, 40. Okay, D, from this line to this line, it is 8. This is 25. From this line to this line, it's 40. I'm just placing it right now. If you want to, you can just make it very aesthetically pleasing if you want. But yeah, this is how you can create a design that you can send it to your manufacturer. If you want a projected view of this, like a top-down projection view, a side projection view, all the projection view you can make. Even if you want 3D projection view, you can just make it like this. If this paper was vertically placed, I could have showed everything. So in sheet settings as well, here change the sheet size remains the same. Edit properties, there is some, yeah. So here I can give the document whatever you give in engineering drawings. If I want, I can select it all. I can just remove it. So yeah. Okay, here I will just undo it. Yeah, there we go. So everything is fitted in this paper. Here they have added extra space so that it can be punched in properly with a file, and I can just export it as a PDF. So it is that simple. If I want to do anything, I will just export it as a PDF and I can submit it as an assignment to my teacher or anything. So yeah, so that was a basic introduction to the CAD designing, how we can convert 2D drawings into 3D shapes and 3D shapes into 2D drawings. Both we have done. We'll see more of it in the later sessions. If anyone wants the link of the book, I am sharing it in the chat. And today it will be all about CAD designing, as I explained. We will be also, by the end of the day, we will be designing our own robot. But before going to the robot, I will be showing some basic geometric designing. Any questions? Or else we can have the break.
Okay. Means directly can we get the front view, top view, side view and all in one shot itself, or we have to create separately?
Yeah, so there are some templates. I've never used templates, but what I do is I can just add a base view. Here you can see projected view. So if I select this, I want a projection view of this. So again, I have to just click over here. I have to just click. You can see I'm clicking in different directions and I will press OK. So I will get views of all of them.
Yeah, got it. This is also very simple. Earlier in AutoCAD, means once we get a 3D, then if we click orthographic, immediately the front, top and side views will automatically come. So this is also equally simple.
Yes.
Okay.
Even if you want a section analysis view, you can add that. There is a lot of more tools. There are geometric edge construction, circle construction, angular radius and stuff. And if you want a note like that, like I will just select this. What was written? Diameter 40 mm. It didn't pop up or not. Oh, wait. Diameter 40 mm. Yeah. So I can just see how much big I want, and I can, if I want symbols, I can add that symbol as well. So all those things you can do. Instead of typing diameter, I can just type this. It will give me something like this, which is exactly like this instead of m. So even once I have placed anything, I can just select it. I can move it around. So I guess modify and move it around. Wait a minute. Yeah, now I can just move this around wherever I want, however I want. Even if I want to change this location to some other location, okay, this is the location. I don't want this. I can just edit it however I want. I can make it look exactly like the one in the this book. This is a really good book. You can refer it for some engineering drawings. Later on, we will be making some more complex shapes like these. And finally, we'll conclude today's by making a complete robot. Okay, and that robot, tomorrow we will be implementing mapping and navigation on that robot. Instead of using Turtlebot or instead of using any other robot, we'll be making our own robot and implementing mapping and navigation on that. If there are any questions, I am here to answer, or else everybody can leave and we can conclude the first session for today.
Okay, sir. Thanks. Sir, you made the complete tortoise bot in Fusion 360 only?
Yes, yes. Even the designs of Tortoise Bot are available. Like it's completely open sourced. So even I will show you if you want to see that. Yes. Yes. So here is the complete Tortoise Bot with all the electronics right from Raspberry Pi to the jumper wires and the motor driver battery, the battery module. Even what we did was we imported this file as a DXF and we laser cutted all the chassis part for Tortoise Bot. So even we have done laser cutting from this.
Okay, even laser cutting was done using Fusion 360.
Yes. Yes. Well, let's say like here I have some sketches. There are a lot of them. I guess the most recent one will be the one. Yeah, this sketch, highlighted sketch. Can you see? This.
Yes, sir. We can see. Yeah.
Yes. So this sketch, what we did was once we understood ki we all want all of these holes and this is the shape, I have just right click, save as DXF. And this DXF, if you send it to any laser cutting manufacturer or something like that, even the signboard makers and the people who make number plates of vehicles and signboards, even they can do laser cutting for you. So if you send this DXF to them, they can laser cut it. So it's a 2D drawing kind of a thing. If you want to see more of it, you can go to github.com/rigbittlab/tortoisebot. Here, I guess, not here, tortoisebot_docs. It has all the documents regarding Tortoisebot. So it has the CAD designs, it has the chassis, it has images. So I can show you the CAD designs. It has the step file, FBX file, Fusion 360 file, the chassis. This will be the DXF. So DXF will be a computer code that you cannot read, but same DXF, it will they can use it on their computers for laser cutting. You can also see an SVG that can be also used for laser cutting. It this is like human readable thing, human seeable thing. You can see. Let it load. Yeah. So this is the design.
No, okay, sir. Thanks.